Good night, everybody. We are live. Yes, good night, everybody. Uh, yes, I went to take a walk. I announced this live session on LinkedIn, in LinkedIn, on LinkedIn. Before going to take a walk, I was playing with some Scala syntax for about 10 minutes. Basic things like to see if you can perform some stuff. In here, this is like Python syntax. This is, but um, equals, and there are some function application and over here in an if, and some ID, identity in Scala. Yeah, some basic, some syntax, nothing heavy. And now, again, it seems like we cannot get rid of the 2 minutes introduction. I don't know. Maybe I should shut up and when clicking start streaming, going directly to the book. I don't know. That will be. I don't know. We will see. Now, exercise. Sorry for 0.5. It is not marked as hard, but I really don't know if we will be able to arrive to a solution for this exercise. It seems a little bit scary. Implement this function. Which one? Traverse. It's explained over here. It's type. Okay, you have to put just we implemented sequence in the previous session, and then there is some kind of elaboration on the need of a more generic function to, because this is a pattern that you will see a lot of times in Scala, and they provide the type signature, which we are going to copy paste, and then it says, yeah, implement this function. It's straightforward to do using map and sequence, but try for a more efficient implementation that only looks at the list once. In fact, implement sequence in terms of traverse. I don't know. I don't know. Okay, it says it is inefficient if you do it with map and sequence because you are traversing the list A's with map to apply the function F, and then you are you apply sequencing the list of option values to end with this result. So more, they want us to avoid the two traversal. I don't know. But we need to, oh my God, 4 minutes. Okay. Here is our chalkboard. In case we need to draw, some guitar. Procrastinating over here, sorry. I should be doing this instead of doing the exercise. But okay, we have our guitar draw. Now, okay, traverse. After 5 minutes, we are going to write codes. So we have this a lot of code. At the end of this, we will be doing some, some cleaning over here, and which will be okay. Yeah, over here. enter. Oh, it didn't paste thing. Oh my gosh. Okay. Okay. Now we have it. Traverse AB ACE is a list of the Scala library. Option for us is the option, and over here is the result type. For us, it will be the option list B. And as always, let's start with the pattern matching version. If we solve it, then we can think of like do it with some higher order functions. So we have the optional list as a result. Somehow we need to end with this, and we need to traverse this ace. How we do traverse a list? We know the drill as match. Well, we don't want the cases generated because case nil. Can we put a nil? No. Why? Because it will be a list, and we need the option of a list. Okay. And since we will be accumulating results for the next elements to process when we are processing the next elements in the list, we will need an accumulator, and that sounds like what we did over here. So let's copy paste this loop and actually the whole thing. And at this point, you maybe will start to say things are getting mechanical. This is not requiring us to do more thinking. But I don't know, still. At this point, let's use annotation to see if we are performing a tail RX. And yeah, perfect. My God, now we are in trouble. I'm calling here an access. We are receiving a list of A. That's what we are going to process. And I will taking a look to this side because we don't want to, be talking and writing and some, some issue causing the streaming to end. But 10 minutes, it seems like a lot. But remember, we spent 5 minutes at the beginning. So I don't know. Please take that into account. List of A. We are going to traverse to iterate over the recurse or a list of A, which is here. And an accumulator, we need an accumulator, remember? We were writing. And the accumulator needs to be the option list of B. Look at this. Why? Because this is the result type. And where is sequence? Yeah, this is accumulator. And then the result type. You guys think we are going we will be able to solve it. That's the thing. X match, which is this. Now case nil. Now we can say an accumulator because it is the option of list of V, right? And in here it doesn't need the type annotation like when we were doing with sequence. With this, if you remember the recorded video, yeah. We are traversing the list again because we are reversing the list, but still, this is like our entry point to get ourselves into the flow. And maybe you can dive in just to this form, but still I am to show this. X match, case nil, accumulator. Now we don't have options in the list. We have a list of A's. What we need to do is say X and a tail, right? Now we can have an option of V with this function application F applied to X, which it will be an A. So maybe better name for this X, it will be A. Or let us stick with X because of these X's. And then try to see. Hopefully you are getting this stuff. F of F applied to X. F applied to X of type A, right? It will give us an option of V, and now we can match case none. Well, none. Some A, some values, right? Or because now there is no maybe A anymore, so probably some X, but no, because we have some A. It seems like some A sounds still good. Yeah, yeah. Okay, and here it will be A's. It seems like I am going backwards, forward, and backwards. So A loop. We are going again over here. Loop. Tail. Tail. Look at this. Map. What's this? Accumulator. Yeah. Accumulator. And F. We don't need to send F because it's over here. And maybe you can optimize this to iterate over to recurse over this instead of doing this. But no, this is okay. And let's hope for the best. Supposedly this should do it in my opinion, but let us see. 40 minutes. How can we test this function with sequence? Maybe these first ints. Yeah, well, let us see if the thing compiles. Okay, we will be spending time. We will be spending time trying to test this thing and we don't have a function. So it is complaining about this maybe a because it's not here anymore. So it will be some a, and at this point you can say maybe you can grab the value over a value, maybe b, and apply the function and then match over the maybe b. But instead, let's do this some a again. I'm not sure if this will be able to fit this, and I'm not sure if this is the memory how it will be because you are doing this. Okay, it is it has compiled over after 16 minutes. Now we need to test the thing. We need to create a list of A's. I'm not sure if this is okay because here is an S, but we don't have an S. I think it's a good idea to actually implement this function with traverse. Do you think we can do that? This is not referent. This is unrelated to the problem, right? So this is outside, and probably these minutes should be taken from our hours devoted to sequence A's. Okay, strings, names. We will need a list of names. I will. Yeah, I will need to delete this for the time being. About names, number names. Number, maybe you don't like this number str, but okay. Otherwise, we will spend the entire night trying to come up with a good name. This is a list of a string. Maybe you don't like annotating the types with types. Okay. A list one. Oh my god. It's parsing. 2, 4. Yeah, I think that's okay. Now parse ints, how it receives an ace. Okay, how can we come up with this? Yeah, traverse. It receives our ace, and now a function. 18 minutes. $19. A. And I don't think this, we should probably test the function in the way it is written in the book. So this is the way in which it is written in the book. Okay. This is because we got rid of the list of maybes, and look at this. There is like probably this is already reported in the errata. How do you say it in English? Errata, errata. Probably some people, said, like this is not okay. Also, probably this function should be called in the a that, but let us still do it, okay? Not found in option. So it is like this. It doesn't like it. Found option in required playground, the option any. What's happening over here? What is the option in base? Find the velocity time 21. It's still there, yeah. We need to take a look into this to put the power. What's happening over here? It's sequencing ace. Yeah, ace. Ace. Oh, what's happening over here? I don't see it. Option int and required the option any. I don't get it. This is like let's use this. Yeah, the option int. It's a new collection by applying a function. What's going on over here? Found option int. Required playground, the option any. Found the option int. Required the option. Oh yeah. Yeah, I know it. Do you see what's wrong? We don't have uh you know, we first the thing is not like there is something over here, probably it was already reported. And uh, this twin option is a function in the Scala library, which is returning an option of the Scala library. And we have the option, we have our own version of the option. We haven't written this for us. So how can we test traverse? Maybe we can leave this option. I don't want, there is no time to, well, this is not a video on how to write, how to convert between the, maybe this, okay, probably that will, I don't think so. Well, this will still because of, let me finish my phrases. This wheel is still not working, as you are saying, because and I have a tendency to not finishing. If you are observing this videos are lots of ideas are coming up, and I am not finishing what I'm saying. But okay, we need to test traverse to see that it's working, and then get rid of this second traversal. And we are running out of time. 25 minutes minus 5 minutes, 20 minutes, 50%. Yeah, this is not doing the thing we want. How can we test traverse? Well, in fact, implement sequence in terms of traverse. So this is like the second part of the exercise. And then if I have some time over the weekend, I'm not promising anything about this. We will see how to use their option with our options. So let's get rid of this. And let's implement sequence in terms of traverse. Def sequence. Sequence prime equals in terms of traverse, so we need to call traverse. Now this is what's going on over here? Let us take a look again at sequence. It receives a list of options A and it gives us an option of list of A's. So traverse is receiving a list of A's, and sequence is receiving a list of the option A's. So maybe there's something wrong over here. Maybe there is something wrong over here. How can we test traverse and then let worry about sequence? What can we do? Maybe some division. Let's write on some division. Def division, the option we are not currying this function. So let's take our things in a tuple. Yeah, int, it's okay, and b, it's okay, and return the option of int, and this will be equal to case b equals 0, saying none. But I don't know because traverse works with one parameter functions. So how can we test traverse without writing sequence first? Without re-implementing sequence first? We have 31 minutes for you. I think I'm going to plug this. Because if what I wanted to do here is like if b equals 0, and we are returning none, and then the division. But traverse, it takes traverse takes one parameter function. Where is it? Here. We can invent like some silly dummy function, if you will. Something like this. A int the option sorry for the function. Okay, dummy to int and this will be equals case 1 1 case 2 2 case 3 first 3, and then anything else like random. We are only converting this. I think now we can implement parse dummy ints. Probably dummy parse ints and now we have first let's try to give me a minute. I'm back. 34 minutes. because someone, like knocked the door and I have to open the door, you know. So sorry. Yeah, let's not get lost in the flow. 1, 2, okay. And yeah, now what? Number, TR, okay. Tell me parse ints. Mm, um, let us see. This should make it. We don't have create a string. Okay, we are missing a the match, you know, and this will be first we were missing like the thing over here, a match, the match for started for starters. Now we were missing this which is indicate that it is a function. I suppose it's compiling. Okay, which is, oh my god, we are running out of time. Now what? I don't get it. It's like there's something I'm not quite get it. Okay, yeah. The returns I got my mind got really interrupted by this stuff. Right now it should be happy. Now it should found a parameter. Now it doesn't like it. Why? Because I mean it should, yeah, yeah. Hopefully you are also discovering the error and the solution. Now I probably should print something over here because we haven't called dummy first ends with number. And now it should okay, some list 1, 2, right? Okay, hopefully you're seeing the entire story. It should be none because we don't have 5. Right, 1, 2, 3, which is dummy parsed int because it's with a sequence. My God. Now, mm, okay. Dummy parse ins um, traverse. This is not. You know, you should choose better names. This is because of the nature of the live session. This is uh, the client code shouldn't be aware of what you are using, and it should traverse the ace and you think it will like it this way? It doesn't. Uh, okay, ace list of string. I got the option in, yes. List of any uh, traverse resets two parameter list. Maybe that's that's why now we got it, you know, with traverse. We have two pending problems. We have 20 minutes. Okay, traverse is doing what it is supposed to do, but we have the problem that this is inefficient because traverses the list twice. Where is it? Because we are reversing the list. Yeah. So we need to uh, now to use fold right or fold left to get rid of this reverse. So it is time for us to do this backup. So traverse. Sequence fine. Yeah, this is for the future. Now we're here. This will be traverse backup. Now this is traverse, and now we can abstract, not abstract, to use higher order functions with, you know, like we did with sequence and map to. Yeah, over here, this is our map to backup, pattern matching, map to, sequence, sequence. Now it is turned for traverse. We are running out of time for sure. Well, remember, we did spend 5 minutes. So what can we do? Well, let's acknowledge acknowledge the fact that it is using an accumulator, and the same reasoning we used with sequence. So let's uh, start writing, but ACE is a list. Let's take that into account. All right. Yeah, now we need the accumulator, and the accumulator is some list. Yeah. Some list empty of type B. This is our accumulator. Now the function. It receives two parameters. Now remember, map2 works with options and a function that takes normal values, normal values, not optional values. Where is it? What is map? Yeah, two options and a function, regular function, and it combines those two. So we need the accumulator, which is B, and we need the accumulator, which is already an option, and we need this to be an option. How can we do that? Well, applying the function over the A. And say, my God, this thing again. Look at this. F of A match. Now we have in the case that it is none. No, I am starting to think that we should be doing this to save time, but it was for explanatory purposes, so it's okay. Now case some B, some value, and in here we can combine with map2 like we did in over here. So let's write by means of copy pasting. Make two. I'm not sure if this is going to work, to be honest. Match A, this on B, and map2 needs this option. and the accumulator to combine them by means of uh, a and copy pasting from up there. Um, uh, yeah, maybe. Let us call it traverse optimum. Optimus Prime, like I don't know, Maximals, some series from the past. This should make it, but I'm not sure of we think we did over here. You know, it is we what happened? Okay, Traverse Backup and Traverse Optimus. At least this stuff compiled. That's quite relief. And we got it, you know. 1, 2, 3. Let's put a 5 over here. Right. Well, that's great. Great. Amazing. Oh my God, 10 minutes and we did spend 5 minutes at the beginning, but it's still 15 minutes for sequence in terms of traverse. It seems like very few, not enough time for me. Okay, we are plugged to the yes. Okay, now time for sequence. Do sequence. Where is okay? We have sequence prime, and it takes a list of the option A's and returns the option list of A. I'm not sure about this function because in sequence it should be like like a list of options of A. We need to traverse Optimus needs a clean list. Well, a list that doesn't include options. So we need to. It seems to me a little bit silly because what sequence prime will be doing, it will be just what is sequence? Yeah, mapping the function A to B, traversing the maybes, the options in the list to combine them. But at this point, we don't have we don't have we have a list of options. but Traverse Optimus expects us to send a list without uh, the options. We're certainly running out of time. We have like 10 minutes, but we can give us another 10 minutes. So I have my chalkboard over here. Remember, now it's time to use it without. Now, this is the problem that I am seeing. In the beginning, we were drawing guitars, and now we get to pay that, with the timing. Okay, we have at least two, I got three, five, seven, nine. And for me, this is silly because if we transform two options, you know, if we wrap up with options, um, and send this to Traverse, uh, it's silly because what Traverse will be doing is taking these options and combining. Let me take another color. Yeah, this one. Uh, yeah, combining this stuff. Uh, that's an option, big option, and put the thing over here. But this doesn't count. So it will take. What sequence do is take this list and grab. Give us a big option container and the list of values if they were successful values in a list, you know. But having this list on the first place, in my opinion, I'm not sure if I am missing something. What we need to do is to say, okay, you're giving me this list. I have a look. Now you have your sequence of values in an option, write and wrap the functions, wrap the arriving values in a sum box, some container. Cierras, Nancy, eh? In my... But that's what I get. That's, uh, yeah, basically, they are giving us a list of option of A for sequence. Well, sequence needs a list of options of A's and a function. No, it doesn't require any option. So yeah, for me, in my opinion, and let's take a look at the time. 1 hour, yeah. In my opinion, sequence, in my interpretation, sequence accepts a list of options and returns this option of the values. For traverse is taking a list, plain list, and a function that converts those. I don't think I am saying quite right this second part, because it's if someone in some client code needs to use sequence, it should have already a list of options of A, you know. The client code calling sequence should already have a list of options of A to pass those list of options to the sequence function, so it can get a big option bit container with the list of values combined. That's what sequence do, but some client code using traverse, uh, it only has a list of A's. So I don't know if I am not understanding this second part, to be honest. Implementing internal service. Yeah, if someone wants to use sequence, you should have an option of A. Probably we will see the answer for this, the second part. Right? Can we? Yeah, I think we can uh, engage in this. I don't know. Let's suppose uh, someone doesn't know about the existence of sequence, and but then I don't get it. Why would you want to use a function you don't want to? You don't know it exists. Uh, when you use sequence, it's because you already have this list of options. But let's suppose someone doesn't know. What's the point of sequence? Is to convert a list of options to an option of list. So if you want to use traverse for this purpose, you will need to transform these A's to a list of options, right? And then return the option of list. Yeah, I don't get this sequences in terms of traverse. Let's suppose, I don't know. Let's suppose you want. Let's suppose you don't have a sequence. You don't have this list of option of A's. You only have this list of A, and you want to combine them into, I don't know, into applying this function to every element, so you can have your list of B's. Yeah, your parameter. I think I'm seeing this backward traverse calling sequence, or it should be sequence calling traverse, but it's even more even more silly, because let's see the time. Yeah, 1 minute and 7. I think the time 5 minutes, 10 minutes. It's okay. We have some videos of 1 hour 20 minutes, and I don't want to record any other video in relation to this. So let's dive in and see if we can solve this in 5 minutes, right? Implement this function, in fact, implement sequence in terms of traverse. If you have a maybes, list of the option A's, you want this is just, I don't know. I don't get it. Why would you traverse needs a plain list? If you grab these values, I don't know. It sounds a little bit weird, to be honest. But let's like drink the Kool-Aid and call traverse over here. Traverse Optimus with a list. Right, we need a plain list. How we do transform this maybe of A's into a plain list. Yeah, I don't get it. I don't want this guy. What it what what's the purpose of this? because you have your baby's age and you want to combine them into a list. But traverse Optimus accept a list of a. Okay, and allow me 10 more minutes. Okay, traverse accept a list of A, but A for us it will be this. This A will expand to this A, to this the option of A, right? I'm starting to see it. This A, it will expand to this, right? So I think we need to send the maybes. Yes. And start thinking how we can we got rid right of that. We need to write more options. Well, on one, the option int released is a list. Maybe one, we will change the name for the values of the maybe one, maybe two, maybe four. I'm absent. This should give us 1, 2, 4, right? Now back over here. Over here, we're sending list of A, list of the option A. What now? I think we need a function. Let us see if we are. Oh my God. Now we have our list of the option A, which is this A. Remember what happened the other day with you know, the flat map. It was this scenario, A, the option A. Now we need an A, the option A, an option B, but it needs to be the same. So I will, use this identity, which takes an A and gives us an A. And run the thing. We have 1, 2, 4. Yeah. My God. We just did it. Rice. 1 to 4, sequence prime. Sequence prime, we take maybe 6. Now this was even harder than the traverse uh, function. Let us see. We are done. We finished. Yeah, 1 hour. Minus 5 minutes. So 11. Yeah, we are in the time range. Period of grace period. I don't know. But yeah, we have traverse, and it wasn't quite straightforward. If you arrive only to this, don't. Let's not worry. It is a tail recursive, but you have the reverse still. But then we shoot for the higher order for right, which it's just encapsulating this form, abstracting over this form. You can take a look. Now sequence, yeah, it was a little bit hard to get at the beginning because you saw, and what's the point if I wasn't getting it at all. I was not getting the point, and when I don't see the purpose of something, I just block my mind, and that happened in, I don't know. I was just blocked, and well, I don't get it. I don't see why you are doing that. But in here, we we didn't quit, and we stick with the thing, and said, okay, this A will expand to this option of A. So this is a little bit I don't know, maybe you are an expert. For me it was like saying some sort of to acknowledge that this is indeed a type variable, and you maybe or me maybe are thinking that it is a value, right? Like this, but it is a type variable. Look at this. Take, take that into account, and probably we will be fine. So yeah, this looks beautiful, by the way, and thank you very much. I started this late at night because I announced this on LinkedIn, and then I went to take a walk, little walk. I was also joining some people that invite me to, some fellows from the past that invited me to, some gather around about some worship. It was cool. So thank you very much. See you any other day. What's missing over here? We did need to take to do these drawings. That helped. Always have. So Leslie Lamport says that in order to think, and he was quoting someone else, but I heard it from Leslie Lamport. computer science, you probably know. And in order to think, you need to write. And I like to write on notebooks, but it is over there, so I need to do it over here. My notebook is like, I don't know, out of reach. And I was already interrupted. You saw that, but okay, we did it. Thank you very much. Now that we have this enormous amount of time, uh, let's 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 be cool. Let's chill out and yeah. Next one, theater data type. Some exercises, but I think I will take a break. Uh, one day probably. So or maybe the weekend. We will see. In the time being, thank you very much and see you in the next live session. Uh, happy coding, as Dr. Eric Meyer say. Happy hacking. So thank you very much and